Hi there. Taping the review for the Unit 6 test review that you will have on your exam day. So the first part, or the first page, is just basic probability. It says one of these names is drawn from a hat. Determine each probability below. So the first one asks and is done for you. It says a 3-letter name, and so I count how many 3-letter names I have, and I have 2 3-letter names out of 10, and then I always simplify, so that's 1/5. So then it asks me what the probability of a 4-letter name is. And the probability, remember, is always equal to the favorable outcomes over the possible outcomes. So I have 1, 2, 3, 4 that are 4 letters out of 10 possibilities. So then I simplify to 2/5. Number 3, it says starting with the name of B. And starting with the letter B, and so I have 1, 2, 2 out of 10, which is 1/5. Starting with the letter T, I have, I have Tina, and I do believe that's all, so it's 1/10. A 7-letter name, I have 1 7-letter name out of 10 possibilities. A name starting with S, I have no names that are starting with S out of 10 possibilities, so 0 out of 10, which is just equal to 0. And a name ending in Y, so I have Mary, 2, 3, 3 out of 10. So again, basic probability, just finding the probability of an event occurring, and so that would be the favorable outcomes over the possible outcomes. So the next section deals with cards, so you kind of have to know some information. If you do not know any information about cards, remember it can be found in your Unit 6 packet on the second to the last page. So it says, what is the probability of drawing an ace? There's 52 total cards, and there's 4 out of 52 aces, and then when I simplify, it's 1/13. And then the probability of drawing a face card was a king, jack, and queen, and there's a king, jack, and queen in every suit, and there's 4 suits, so 4 times 3 is 12, divided by 13, which is 52, which simplifies to 3/13. Probability of a red 10, where there are 2 red 10s. There's a heart that's a 10 and a diamond that's 10, and both of those are red, and so I simplify to 1/26. And then not a diamond, so there are exactly 13 diamonds, so I would take 52 minus 13, which would be 39 out of 52. And then I can simplify that, or can I simplify that? I think it is equal to 3/4. The next one is a spinner numbered 1 through 8 over here to the side, and what is the probability of spinning an even number? So an even number, 2, 4, 6, and 8. There are 4 even numbers out of a total possibility of 8, so it's 1/2. Number 13, a multiple of 3. So my multiples of 3 here are 3, 6, so there's 2 of them, out of 8, and that would be 1/4. A prime number. So a prime number is a number that is only divisible by 1 in itself. So my first one is a 1, my second one is a 2, third one is a 3, 4 has 2 times 2, 5 is prime, 6 is not prime, 7 is prime, and 8 is not prime. So I have 1, 2, 3, 4, 5 out of a total of 8 numbers that are prime. And then a 9, there is no 9 there, so there's 0 possibilities out of 8 total outcomes, or 0 favorable outcomes out of 8 possible outcomes. Now, the next thing has to do with complementary events, and we talked about this, but the easiest way to talk about it is what this says is the probability of something happening. So, for instance, when I give you the situation, the probability of raining plus the probability of not raining, you guys told me that adding those together is equal to 100% or 1. Because if I told you the probability of raining was 30%, you would, to find the probability it's not raining, I would take 100 minus 30%, so that would be 70% is not raining. So this would be 1 or 100. the probability of something happening and its complement would add up to be 1 or 100, depending on if I'm in decimal form or percent form. So here it says, suppose an event A has a probability of 3/8. What's the probability of not A? So basically it would be 1 minus 3/8, which is 8/8 minus 3/8. And so my probability would be 5/8. And then it says, suppose the probability of snow is 0.58. What's the probability that it will not snow? So again, I'm out of 1 because I'm dealing with a fraction or a decimal. And so the probability that it will not snow is 0.42 or 42%. The next section deals with inclusive, which is also called not mutually exclusive. You can use that either way, versus mutually exclusive events. So there is a formula, and I had several people that were coming in saying, well, what do I use? The formula is right here, guys. So if A and B are mutually exclusive, that means that they happen without an intersection. So these two events do not have an intersection, do not have an intersection. Okay, meaning there's nothing to subtract. So over here, if I was to plug it into the formula, the OR formula, and it's in an OR situation, that's when we have either mutually exclusive or not mutually exclusive, I'm basically subtracting 0 because my intersection is 0. So I just end up adding the two probabilities together. Well, if they are inclusive, there is an intersection. So there is an intersection. So therefore, I have an intersection to subtract. And as we go down here and use it, I think you'll understand some. So we're dealing with a deck of cards. So in this situation, it says, what's the probability of drawing a king or a queen? Well, the probability of drawing a king is 4 out of 52, and it's an OR, so I know I'm going to add, plus a queen. There are 4 queens out of 52 cards. And then I'm even going to go ahead and put it, there's nothing to subtract. It can't be a king and a queen at the same time. So therefore, I subtract 0, and my probability is 8 over 52. And then when I simplify, it's 2 over 13. The next one is a red jack or a black king. So a red jack, the probability of a red jack, so this means the probability of a red jack or the probability of a black king. So the probability of a red jack is 2 out of 52. Plus the probability of a black king is 2 out of 52. So that would be 4 out of 52. So my answer is going to equal 1 out of 13. And again, there's no intersection, so I'm actually subtracting 0. So in this case, it's going to be mutually exclusive again. And I'm going to go ahead and write that down because that's going to help us in a second. And number 18 was mutually exclusive, indicated by the subtracting 0. No intersection. Okay? And it can't be a red jack and a black king at the same time. No intersection. A face card, so we said before there are 12 face cards, or a card with a prime number. So face cards don't have numbers, so I know there's no intersection, but I do have to figure out what are prime numbers. And so I have 2 as a prime number, 3, 4 is not, 5, 6, 7, and I think that's it. So there's 4 in every suit, so that would be 12 out of 52. So that's going to be 24 out of 52, and that's going to be 6 out of 13. And again, this is mutually exclusive. Nothing to subtract. The next thing says an even card or a red card. So in this situation, an even card would be 2, 4, 6, 8, 10. So there's 5 in every suit, so that would be 20 out of 52. Or a red card, and a red card is basically half the deck, so 26 out of 52. And then you have to think, I have 5 red even cards. Actually, I have 10 red even cards. I have 5 diamonds that are evens, and I have 5 hearts that are evens. So I have to subtract the intersection. So when I subtract the intersection, that makes it not mutually exclusive, or you can call it inclusive also. Either word, you can know either word. So, and then I just simplify from here, and it's 9 over 13. So the key here is, do I have anything to subtract? A spade, there are 13 spades out of 52. There are 4 jacks out of 52. And then there is 1 jack that is a spade. So that would be 16 out of 52. So that would be 4/13. And again, this is not mutually exclusive, because it is inclusive, because I'm subtracting something. So then moving on to the spinner situation, I'm going to use the same formula because I'm doing OR. An even number, so my spinners 1 through 10, so I have 2, 4, 6, 8, and 10. So there's 5 out of 10. Or a power of 2, so 2 to the first, 2 to the second, which is equal to 4, 2 to the third, which is equal to 8. So there's 3. So plus 3 out of 10, and then I have to find the intersection, and I have a 2 and a 4 and an 8. So minus 3 out of 10. So in this situation, my answer is going to be 5 out of 10. Because every power of 2 that is even. So I have to subtract the 3/10. So this is not mutually exclusive. An odd number or a power of 2. So I have odd numbers, 1, 3, 5, 7, and 9. So again, 5/10, plus the powers of 2, which is 3/10. And then I don't have anything to subtract. So it's basically 8/10, which is 4/5. So my answer is 4/5.
You're thinking out loud.
A number less than 8 is 1, 2, 3, 4, 5, 6, and 7. And then a divisor of 15 is 1, 3, 5, and that's all, because 15, and 15. So then I have to think about what is my intersection. So here I have 1, 2, 3, 4, 5, 6, 7, 7 numbers out of 10. So, and then I have plus 3 out of 10. And then I have to subtract my intersection, and I have 3 numbers that are the intersection. So then my answer is 7/10. And again, I have something to subtract, so it is mutually exclusive. And I will continue the video on the next one.